Hello, today we are going to cover 2.1, relations and functions. After today, you guys will be able to graph our relations and identify functions. So we can represent relations in 4 ways. Make a table. The first way is called ordered pairs. So we are talking about relations. A little fancy curvy bracket just is describing that this is a relation. And I have just random set of coordinates that I'm coming up with as our points in our relation. We'll use the same set of coordinates for all 4 types of relations, or ways to write relations. So that's a set of ordered pairs that makes up a relation. Our second thing is a table. I like to call these t-tables. We have x, y values, and you just write your coordinates in their respective x, y column. Our third way is a graph. So I go ahead and graph my points. -2, 2. -2, -2. 0, 1. And 3, -4. And lastly, we have something called a mapping diagram. So this is where we have inputs, or our x values, in one box, and our outputs, or y values, in another. And it's called a mapping diagram because we map arrows between them. So in this first box, we don't have to repeat the -2. If we write it once, we don't have to write it again. And the outputs, we write them all. There's no repeated ones. And -2 goes to both 2 and -2. 0 goes to 1, and 3 goes to 4. Sorry, -4. So our domain of our relations is our x values. You can also think of these as our inputs. Okay, so these are a set. So we have -2, 0, and 3 as our domain. Our range is our y values, or our outputs. So that's 2, -2, 1, and -4. Alrighty. So now we decide with our relations if they are functions or not a function. So we can look at each of those kinds of relations and decide function or not, based on what we know. So we're first going to look at a mapping diagram. We have our inputs, our outputs. These are new examples. So we have -3, -2, -1, 2, and 4 in our inputs, and 2, 3, and 4 as outputs. Once again, we need to map these. So -3 maps to 2, -1 and 2 map to 3, and 4 maps to 4. So you'll notice here that each input goes to only one output. So this is considered a function. Okay? Now, we also can do something similar with t-tables. I'm going to use different numbers to demonstrate. So we have 1, -1, 2, 4, 5, 4, and 7, 8. This time, we can look and see the x values are all different. So although there are repeated y values, we care about the x values. So this is a function. And then lastly, we can look at a graph. We have something called the vertical line test. So if we have a graph and it looks like this, if we can draw a line that never crosses more than one point of our graph, it passes the vertical line test. So you'll notice it only crosses the green graph one point at a time. So this graph passes the vertical line test. So we have a function. It must pass to have a function. Now in your homework, you're going to have some questions sort of like this that ask you to find the domain and the range. On a graph like this, it's kind of hard to imagine, but this graph actually extends to all real numbers in the x-axis. So our domain would be x is all real numbers a fancy way to write that is like a double R, or sometimes they write it -infinity is less than x is less than infinity. That's just saying x can be any number between negative and positive infinity. And then our range, our range we'll say is at 2, and we're talking about our y values this time. So our y's start at 2 and will only increase as they go up. So our range is y is greater than or equal to 2. Now we have not a function. So once again, we have inputs and outputs. I'm going to copy this over. Erase my numbers inside. Okay, so now we're looking at things that are not functions. So if our inputs are -2, 1, and 4, and -4, -1, 3, and 7 are our outputs, and -2 maps to both -4 and -1, 1 maps to 3, and 4 maps to 7, this is not a function because the input -2 goes to -4 and -1. So this is not a function. For our x, y table, we have the values 1, -1, 3, 7, 3, 4, and 5, 9. This one is not a function because there are 2 3s as x values. Lastly, on a graph, if we have a graph like this graph does not pass our vertical line test. It crosses more than one point. On our green graph, crosses 2, 2, 2, 2, 2, 2, all the way. So this fails the vertical line test. So it is not a function. Right, and then the last thing, kind of completely separate, we have something new called function notation. Function notation is basically this right here. You say it f of x. That's how you say this notation down here. F of x just basically is saying the same thing as y. But now, if you see something written out like this, instead of saying y equals -2x plus 5, plug in for x equal to -3, they just say it like this. That means the same thing. X is -3. So we plug it in. -2 times -3 plus 5 is 6 plus 5, or 11, once again. X is 0, so we'll plug 0 in to our expression. So 0 plus 5 equals 5. And this time we plug in 1/4, or 1/4. And this is -1/2 plus 5. There's a couple ways you can write this. You can write this as 4.5. You can write this as 9/2. You can write this as 4.5. And those are all correct solutions for that one. Alrighty. That is it for our lesson today. Have a great afternoon.